All right, so here we go with our final conic, and that's a parabola. I know we've talked about parabolas in Algebra 2, and we've looked at them already this year in terms of graphing. Now we're going to look at them in a little different light. Um, what we're going to look at here is it's a set of all points in a plane that are the same distance from a given point, called the focus, to a given line, sorry about that, called the directrix. So here's my focus point right here. And this line down here, the green one, that's what we're going to call the directrix. So if I picked any point on here and looked at the distance from the point on my parabola to the focus and compared it to that distance, which again would be the perpendicular distance from a point to a line to the directrix, those two would be the same. And I could do that for any one of my points. Okay, so we have your focus point. Okay, there's my vertex, which again is a point where we change direction. What we're also going to have here is a line of symmetry that we can fold it over, and every point on one side would fall on a point on the other side. Okay, now what we're also going to look at is there's an important distance that we're going to talk about with a parabola now. We're going to talk about that distance as P. Okay, because P is the distance from my vertex to my directrix, as well as the distance from my vertex to my focus point. And to help us graph, what we're going to find out is if I go from my focus point perpendicular to my line of symmetry, okay, there's going to be a distance of 4p total. So we're going to go, once we find this value for p, 2p, you know, to whichever direction, because we could open up left or right, up or down. Okay, so we're going to go and use that distance to find a couple more points to help us graph. Okay. Now, the direction of opening is the thing that comes into play as well. Here's the one that we all should be very, very familiar with. When we have y equal x squared, obviously we know that that's a parabola and it opens up. Okay, if we take the opposite of the x squared, that's when we're going to open down. Now, what's going to change here is if we open left or right. Okay. If I have x equals y squared, so my y piece is squared, and if we go back to the idea of solving for y, what we have to do is take that square root of both sides, and if you remember from our families of graphs, the positive square root piece gave us that part that's up here, and then what happened was when we took the negative square root, that gave me the reflection, so that gave me the bottom half. Okay. If we have the opposite of my y squared piece, that's where we're going to open to the left. So a lot of times they won't ask you which way does it open, but it's always a good idea to think about it and write it down. Okay. So same idea, we can have a couple situations here where, you know, or a couple different equations, I'm sorry. One telling us if it opens up or down, one if it's left or right. And it all depends on which variable is squared. When my x is squared, that's going to line me up to be up or down. And again, how we know which way is if my 4p value, which we'll look at here in a little bit, is positive, we're going to open up. If it's negative, it's open down. Okay. And when y is squared, okay, when we look at that 4p value, if it's positive, we're going to go to the right, negative, we're going to go to the left. And again, be careful with your ordered pair there, because h and k, again, is my vertex. But x is with, or I mean h is with the x. Okay, don't just think of it as the first piece. And k is always with the y. So you got to look at it as x and y's. All right, so in this case, number one, what I'm going to look at is which way are we going to open up. And because my x is squared, I know it's going to be up or down. But because I'm positive, that's going to tell me that we're going to open up. Okay. So this one's going to open up. Now I'm going to get my vertex. And again, I can always add or subtract 0. So now I can see my h value, what's with the x, 0. What's with the y, which is 1. So at 0, 1, that's going to be my vertex. Okay, and one of the things that I always do is when I do put my vertex on there, I'm just going to kind of go like this so that I remind myself that it's going to open up. Okay. Now, my line of symmetry. Because I drew that little curve here, again, that makes it a little easier to see that, hey, it's going to be vertical. It's going to go up or down, but it's got to be an equation. It's a line, so it has to be an equation. Okay, up and down is your x equals. Okay, and I can always look at my vertex, x equals 0. Now, your value for p. The number in front of the set of parentheses is 4p. So 4p equals 12, meaning p is going to equal 3. Now, how I use that 3 is I'm going to go on my line of symmetry from my vertex. I'm going to go up 3, and I'm going to go down 3. Okay. Because I kind of sketched this curve out again, my parabola, now I know the one inside is going to be my focus. So I can identify my focus now because from my center, I went up, so my x value stays the same, 3. Now, my other point then is for my directrix, which is also a line, so I need to have it as an equation. Okay, and since the other one was x equals, I know this one's going to be y equals with the horizontal. And where did I go through? Y equals -2. Okay, so I've identified all my parts. Now I just need to finish my graph, and that's where that idea of 4p being this segment that basically goes through my focus. So what I'm going to do is take that 12, cut in half, and go 1, 2, 3, 4, 5, 6 to the right, 1, 2, 3, 4, 5, 6 left. And now I got a couple more points to help me graph my parabola. All right, so if I got to complete my square again, and again, there's a separate video for that. What I want to do first is, again, get my x stuff together, my y stuff together, my constant on the opposite side. How I'm going to change that this time is my squared stuff is going to go on one side. And the rest goes to the other. Okay, so because my x was squared, I kept all my x stuff on the left side. Okay, but then I threw my y and my constant over to the other side. Now, should go back and say that how I'm going to know that I have a parabola looking at my general form is that a or c is going to equal 0, one of those two. Okay, or we can talk about as only one squared piece. Okay, either x is squared or either y is squared, but not both of them. Okay, and so now when I go into that next step of getting my quadratic coefficient to be equal 1, okay, there's only one squared piece, so I only have to worry about this case getting my x squared piece having a coefficient of 1. And so I factored out my 2. Okay. And I'll complete my square just like I've been doing by taking half my linear. Okay, so half of -4 is -2 squared is +4. Okay, but again, I got to think about the distribute piece. And so I actually am adding 8 to both sides. I'm going to rewrite it as a perfect binomial square. And then over here on this side, combine my constant pieces, so I get y plus 2. Now, what I'm also going to do in my next step here is I have to make my linear coefficient equal to 1. And so we talk about linear, we're talking about the non-squared side. And so what I have to do is, I don't want -1 there, I have to factor out that -1, and again, be careful because I have to take it out of the +2 as well. And then the last thing that I want to do is I want to make sure that my perfect square, my binomial square, doesn't have a number out in front of it. I want it to be a 1. So what I did here is I divided by 2. And now when I divide by 2, I'm going to divide it into the piece that I just factored out. Now I have my standard form. Now I could go about graphing it. All right, so to write an equation, same idea as those other ones. What I want to do is I want to sketch again what's going on because it makes it a lot easier. My vertex is at -5, 1. Okay. And my focus is at 2, 1. Okay, so putting those points in there, what I know again is because it's a parabola, my focus is inside that parabola. So I know it's going to open to the right. So what I know is that my y is the piece that's squared. Okay. And so I also know that my 4 piece is going, or my 4p part is going to be positive. So I can go like this: x equals, and then my y squared. Okay, so my vertex, the x piece is -5, so it becomes +5. Okay, my y piece is 1, so it becomes -1. Now remember, this distance right here is p. Okay, so when I look at that distance, it's from -5 to 2, it's 7. Okay, and so what I want, though, is not 1p, I want 4p, which is 28. Now, always put that with the non-squared piece. Okay, so that means it's going to be 28 is going to be with the x plus 5. Okay. And there's your equation. Another one, vertex at -4, 5 opens to the left. So at -4, 5 is my vertex, opens left. So that tells me I'm going to have a negative value for p, and also that my y piece is going to be the squared piece. Focus, it's 5 units from the vertex. So there's my focus. It's 5 units away. Okay. So like we said, the y is the part that's squared. So x is with the -4. Y is with the +5. And since that focal distance is 5 units, that's the value for p. So 4p is 20. That goes in front of your linear piece. All right, good luck with parabolas.